Thank you all for joining. Good morning, good afternoon, depending on where you're located. My name is Stephen Feltner. I'm a solutions architect here at Spot by NetApp. And today we're going to be going into a EKS workshop where I'll be talking about implementing serverless scalable Kubernetes in the cloud. My agenda today is going to be a quick 10-minute presentation just to give you a quick overview of what I'll be talking about. And then we're going to go into a live demo of not only showing the challenges with Kubernetes today in the cloud, but also how a solution by Spot both addresses that and can solve those problems. All right, without further ado, let's jump right into it. So just a level set for everyone here on the call, I just want to kind of talk about the anatomy of Kubernetes. So if you're familiar with Kubernetes, there is a control plane where your master nodes reside. This is where the API server is, the etcd plane. And then you have the data plane. This is where your worker nodes reside and where all of your services, formerly or known as microservices, will get deployed by some form of controller type. So there's really two different layers within Kubernetes, and we're going to touch on both of them. So the first layer is the underlying infrastructure. This is where your nodes reside. And then you have the application layer. And this is where your microservices live, where you're deploying pods. There are two elements of scaling. You need to scale both the application, your pods, and you need to also scale the underlying infrastructure so your applications have resources to run on. Now, there are challenges with both. And before we jump into the challenges, I want to talk what solutions are available today to scale both of these layers. So first, today Kubernetes offers what's called a cluster autoscaler. This is a open source autoscaler that's going to assist with scaling the underlying infrastructure within Kubernetes. And real briefly, the way it works is it's waiting for pods to go into a pending state. So the Kubernetes scheduler identifies that there is a pod that needs resources. As soon as it's in a pending state, if there are no available nodes within the cluster that can satisfy that specific application requirement, it will go ahead and launch a new node so that it can then be scheduled. On the flip, if a node becomes underutilized or 50% or less, then the cluster autoscaler will then reschedule those pods to other available nodes and then scale that node down. Again, this is for the infrastructure layer. Now, for scaling on the application layer or your pods, today there are two main ways to do that. One is the horizontal pod autoscaler, and one is the vertical pod autoscaler. And I won't go into too much detail here, but the main highlight is the horizontal pod autoscaler is simply looking for a specific metric and then is going to add additional replicas or additional pods and services to satisfy the specific metric. Vertical pod autoscaler, on the other hand, is actually going to leave the number of replicas the same, but it's actually going to increase or decrease the size that it's requesting. Okay? And both will have some form of cooldown before another scaling action can take place. So again, both of these are great items or ways to scale today, but there are still challenges when it comes to scaling Kubernetes. So again, one thing I always like to say is Kubernetes was originally designed for an on-premise data center where resources were always up 24/7, always available, and you were just assigning applications to available worker nodes. With the cloud, that entire model has shifted to only have compute running when you actually need it. So what the big problem here today that we're trying to help solve is regardless of what orchestrator you're running, we want to help meet the application demands at all time, but ultimately making sure that we're minimizing waste, idle resources, whether that's compute, data, etc. We want to make sure that that is not being wasted. So there's really three ways to go about solving this problem, right? One is the instance sizes. You can use a variety of different instance types and sizes in the public cloud, but that often has its own challenges. Some applications require more or less resources. So how can you ultimately make sure that the size of your instance is appropriate for your applications? Lastly, the other item is the instance lifecycle. Instance lifecycle is really important because you may need a blend of different instance life cycles, which is essentially a commitment, whether that's a excess capacity like a Spot instance, or if you're using on-demand or list price instances to meet your specific requirements. With all of this, the last item is how can we effectively assign the pods to the best nodes? And we call this pod right sizing, often called bin packing. So these are some of the major problems with scaling today is how can we scale effectively so that we can both meet the application demands but limit that waste. And I'll talk about how we're going to address those problems, as well as I'll be demonstrating those problems in real life. So this is where we believe there should be a different approach to scaling so we can address those specific problems. So we believe that containers should define the infrastructure that you need. And what I mean by that is the applications are what we call the first-class citizens. So they're going to be the ones that define the size, the type, the pricing, etc. So here I have an example. I have a small pod or a small application that's requesting a small amount of resources. And based on that, we're going to select a smaller instance, such as a T2 medium. I have an application that's much larger. This will then want to automatically select a larger instance that is suitable for that application. Even more so, maybe you have some machine learning or you need GPU specific workloads. We want to make sure that that specific application has a node that has or contains a GPU. And then lastly, maybe you need a workload that must have the 949 SLA on demand. So you should be able to define that all within your application so you can get exactly what your application needs with the underlying infrastructure. So as I mentioned earlier, there are various different control planes, different orchestrators, and we believe that very similar to a managed service for the control plane, we want to help manage the data plane, which is the worker nodes and the pods that run on them to both solve those scaling problems I talked about earlier, as well as help with effort, time, deployment, etc. So what does it mean to have a serverless or nodeless experience? And really what that means is you should have no management or no intervention of those worker nodes or the underlying infrastructure for your applications. We believe that you should also scale based on your application requirements all in real time. And then another item too is going back to eliminating waste. We want to make sure that you are paying for only what you use. There's no sense in having a bunch of nodes scaled up with no applications running. Lastly, the other item too is it's very important to be able to scale fast so that when traffic is increasing for your specific applications, your end users are not experiencing any slowness or rejections. And then on the inverse, when there is no traffic, we should be able to scale down to zero. These are very important items that we'll address because scaling should meet the application demands all in real time. So let me give some examples of why this is important and how this is important. So today, many customers that are leveraging Kubernetes is going to find point or pick a specific instance type and size. Here's an example with AWS. I have a single pod or a single application that requires 6,500 megabytes of RAM and 1.5 virtual CPUs. I've determined that the best instance type for that application is actually an M5 large. I'm getting 75% utilization on CPU and 81% on memory. Those are pretty decent numbers. Now, as my application scales, I'm just going to be introducing more M5 larges. So if I need 3 of the same pods, I would have 3 M5 larges. So in this example, we're showing that by seeing the overall request, you're actually able to strategically select a much better instance, for example, an M5 2X large with 5 replicas, where we're able to achieve 98% of that memory utilization and 93% of that CPU. This ultimately is going to achieve almost 20% additional allocation versus the counterpart of the M5 large. So again, this is just an example of how seeing the specific pod requirements and using different instance types and sizes, you're able to get a much better cost per pod and much better allocation. So let me talk about some of the other benefits that Ocean by Spot, which is our product for Kubernetes. So again, as I talked about earlier, the container-driven autoscaler is our entire premise. We want to detect what the application needs and then strategically place the workload on the underlying infrastructure to both solve the scaling problems as well as eliminate waste. The entire product is going to help simplify operations. Again, I like to say a hands-off approach with the infrastructure so that you can focus your efforts on the applications and the revenue generating items and allow the infrastructure to be managed by a software or tool. Some other very important items is in a shared environment or a shared cluster, we often see many customers are using both different business units, different applications, different services, and it's important to show not only which applications are consuming what, but also in a dollar. So you can identify what each task, pod, or even namespace is consuming, both from a resource standpoint and from a dollar standpoint. Next is the only way we can really optimize that underlying infrastructure is if the applications themselves are optimized. Oftentimes, many customers will go through an exercise called right sizing. And what's really important about right sizing is nobody really enjoys doing that exercise, whether you're DevOps, a developer, or engineering. What we've done in the Ocean platform is added a resizing or a vertical container recommendation platform that it will identify if any of your applications are underutilized. For example, a developer will say, I need 5 CPU, but over a 7-day period, it never consumed more than a single CPU. We'll make these recommendations on your behalf so that you can optimize the application so the underlying infrastructure is better suited for the actual application requirements. And then lastly, the one thing I like to highlight is we are a platform agnostic tool. So oftentimes we will work with customers that are leveraging infrastructure as code, whether it's Ansible, Terraform, CloudFormation, just so we can help automate that entire process. And if you're not comfortable with the UI, you can do everything with infrastructure as code. All right, I'm going to jump right into the demo. To start off, I have created a EKS workshop. Basically, I've gone ahead and created an EKS cluster just by using the UI. So first, I'm just going to verify that I have access. And you can see I have a single node that is running inside this Kubernetes EKS cluster. So the first thing I want to demonstrate is today I have a variety of different pods and application sizes. And the first thing I want to do is just demonstrate what out of the box EKS will provide. And then if you were to add a cluster autoscaler, for example, kind of the issues that may come up. So today I have a variety of different deployments. I have a small, medium, and large, which are all of different sizes. And just to quickly show what they look like, I'll just go into one of these. So for example, the small is just going to essentially be consuming or making a request for 0.4 CPU and about 1 gig of memory. This is a very standard Nginx pod, nothing special, but just want to demonstrate how this scales. So you can see I've set this as a replica of 3. So let's see what happens when I go ahead and scale this specific application when I only have a single node. So let's take a look. I'm going to get my deployments, and you can see all my deployments today are at 0. So let's go ahead and scale one up to see how Kubernetes behaves with this scaling event. So I'm going to go ahead and say, okay, scale replicas, we'll do 3. And we're going to say this is a deployment in EKS workshop medium. I'm sorry, let's do the small. Okay, so I've gone ahead and scaled up the small application to 3. And now what you'll see is the deployment is now set to 3. And what we want to see is what happened to those pods. Where were they scheduled and how did they scale? So if we just take a look, and go ahead and clear this out for everyone. Oops. So what you can see is all 3 are now running. Because they were small enough to run on a single node, you'll see that no additional node was needed. So these small deployments, there are no issues. So let's go into the next one. I'm going to go ahead and scale the medium. And the medium is requesting a larger amount of resources. Okay. So what you'll see is I've gone ahead and scaled a medium-sized application. And what you'll see is they're not scaling. And we want to determine why. So what happens is this is going to go into a pending state. Okay. So these pods are now in a pending state because there are no additional resources available on that single node. So what I've done is I've added a cluster autoscaler, which is a Kubernetes scaling mechanism out of the box. And what it's going to do is you'll see this is the logs from the cluster autoscaler. And you're going to see that it's identified that there are some unscheduled pods. What is it going to do? It's going to go ahead and increase and launch another node. So what you'll see is, if I can find it, you'll see only has 1 instance. And what they're going to do is they're going to scale the EKS up to 3. Okay. So if I come back and check, I should now see get nodes will now have an additional node. That additional node again was automatically spun up because I had pods that were in a pending state. So far everything is working as designed and really well. Let me kind of show you where the problems will start to arise. So again, if I check my pods, you can see they are now starting to be created. And shortly they will go into a running state. So today, the way I have my cluster autoscaler defined is I'm using a single autoscaling group, and this autoscaling group is going to be using a T2 large. Okay, so basically any workload that would fit within a T2 large is perfect. We'll scale up and scale down based on if there are underutilized nodes and if there are any pods in a pending state. The way I've set the cluster autoscaler is simply by just enabling these tags. So let's take a look at, now that I have these running, let's see what the overall utilization is of these nodes and see if there's any waste. Okay. So I have my dashboard here, and I'm just going to pull my token real quick. And what you'll be able to see is the overall utilization of each of these nodes. So today I have 3 nodes. And what I want to point out is that each node is about 80, 85%, and this one's at 45%. This node only has a single pod running, a single medium pod. What's important here is the cluster autoscaler is going to try to downscale this node because it's under 50%. Well, this is going to be problematic because the pod that is on this node is not able to be scheduled anywhere else. So again, if I just go ahead and jump back, you'll see all of my pods should now be in a running state. I now have 3 nodes. And what will happen is the cluster autoscaler is going to see that one of my nodes is underutilized. Let's scroll down to the bottom here. And you can see right here, it's calculating which nodes and what their CPU utilization is. And you can see anything over 50% is not going to be scaled down. Okay, let's take a look. Now, so this could be problematic because from a Kubernetes perspective, there is a lot of waste. If we were to select maybe different instance types and sizes, we could ultimately get this down to 2 nodes. As I mentioned, there are still a lot of remaining resources on these nodes, especially this one who's only at 45% allocated. Okay. So next is, let me show what happens when let's say I have a developer or team that needs an application that's much larger, maybe like a machine learning workload, maybe a very specific data processing workload, something that needs a lot more resources. You know, in theory, anyone should be able to throw any size application within your Kubernetes and it should scale automatically. However, that's not the case. So again, if I take a look at my large deployment, what you'll see is this large deployment is going to be requesting 4,000 or 4 virtual CPU and 7 gigs of memory, give or take. Well, this is well above my normal T2 large that I defined in my auto scaling group. So what's going to happen? Well, let's take a look. I'm going to go ahead and scale this up. Okay. And now that I've gone ahead and scaled it up, you'll see I now have 3 desired and 0 running. Okay, let's take a look. So the pods have gone into a pending state, and in theory, the cluster autoscaler should be able to take this and launch. So let's take a look. What we see is down here at the bottom, you can basically see that here are my large pods. And what's happening is the new node that would be launched, a new T2 large, is not going to have enough memory or CPU to satisfy that application. So what happens? Well, the pod is going to remain in a pending state and it's not going to be scheduled. The owner of this Kubernetes cluster is now required to have some manual intervention to get this pod up and running. So what would it take for a normal individual to get this up and running? Well, you would have to make an entirely new auto scaling group. I would need to define a much larger instance type. And then I'd have to register and set up all the entire bootstrap arguments. All of this added effort and work is going to be required in order to get that pod up and running. So oftentimes I find many Kubernetes users today are making many different applications or auto scaling groups to satisfy the different requirements. And this is a very manual and tedious process because you're constantly creating new definitions for the various applications that your developers would like to run. So there must be a better approach to this, and that's where Spot comes in. Spot is not only going to remove this entire overhead of managing auto scaling groups and their specific instance types and sizes, but we're going to strategically do that on your behalf. So I'm going to show how fast and easy it is to not only start using Ocean by Spot, but also how easy it is and how easy it is to save money, but also remove these scaling challenges. So before I do so, let me go ahead and remove my pods. And again, if I were to check my dashboard, you'll see that I have 3 pods that are stuck in a pending state with no way to become scheduled. Okay. So what I want to do is I want to show how easy it is to get started. If I already have a Kubernetes cluster within AWS, again, it can be EKS or any other orchestrator. Today, I'm going to focus on EKS. So what I'm going to do is I'm going to go ahead and just scale all of this back down to 0. All right. So I've gone ahead and just scaled everything down so that we can just show this over with the Spot Ocean autoscaler. Right, so you can see everything is now put back to 0. And what I'm going to do is I have set up I've essentially set up a Spot organization. It's very easy. You are going to use a cross-account IAM role into your AWS account. It's as simple as signing up with your name and email address. As soon as you do so, we have a CloudFormation template that will add the needed permissions to your account. And once that cross-account IAM role is available, you can begin importing workloads and immediately benefiting from the platform as well as the cost savings. So today for EKS, I'm going to migrate my worker nodes from EKS. So we're just going to select from EKS. I'm going to call this EKS workshop. And we'll just give the identifier the same name. If I could type today. And I'm in US West 2, which is in Oregon. And what I'm going to do is I'm going to go ahead and import it from an existing auto scaling group. So my auto scaling group was called EKS Workshop. I can do either or, they're identical. Okay. And I'm just going to say next. And what it's going to do is it's going to import all of the configurations, your tags, your user data, your security groups, your instance profile, all of that information is automatically imported in. So you can see it knows exactly what VPC I'm in, all the subnets that I would like, what security groups, if there are more than one. All of this again was imported in, and you'll see it will also add any additional bootstrap arguments. If you're using labels, taints, etc., they will all be imported in as well. Okay. So now that I have all of this imported in, again, all my tags, I'm going to go ahead and click on next. So what's very important is very similar to how the cluster autoscaler from Kubernetes works, is we need a single pod running inside the cluster to identify what those workloads are using and consuming, so we can strategically place them on appropriate nodes. So in order to do so, we're going to go ahead and install our controller. This can be installed using kubectl, can be done using Helm, Terraform, etc. But today I'll just show quickly. I'm going to create a token. Okay, and just for best practices, the token is only going to be shown once. And the reason we need a token is because the Kubernetes is going to communicate securely on HTTPS using API so that the information is sent from your Kubernetes cluster using HTTPS into our console so we can see what is the best node to launch. All right, so I'm just going to go ahead and copy this and pretty much just go ahead and run it. And now I will have a single pod installed, managed by a deployment. So if I get and we install it in the kube system namespace, what you'll see is we now have a controller pod. So same thing, if I were to get the pods in kube system, you'll see I now have a single controller pod that is now running. Okay. Now that I have that pod running, we should be able to say test connectivity, and I now have access, or I have connectivity with that specific pod. I can go ahead and hit next, and I'm pretty much done with the entire import process. Now, as I mentioned, if you wanted to do infrastructure as code, we have all of the API JSON here, as well as an auto-generated Terraform. And this is a good point for me to highlight. We are an official Terraform provider, and you can see if you already manage your EKS cluster with Terraform, you can simply add our provider to the top, and it will create the needed resources within Spot. All right, so let's go ahead and say create. All right, so now that I've created my cluster within Spot console, you'll see it's imported everything, but we haven't launched any nodes managed by Spot. What we're seeing here is we'll see no loads are launched, and we're going to launch a new node. We're going to leverage the best pricing models. Again, this example is in AWS for EKS. So the pricing models are excess capacity known as EC2 Spot. There is commitments such as RIs, and then you have on demand. So of those three pricing models or life cycles, we're going to always pick the best one or the cheapest. Okay, so what you'll see now is this is going to scale up. And what I want to do here is take a look at my nodes. We should see one is in a not ready state. Not yet. It's done already. 32 seconds. Okay. And what that means is we've now quickly were able to spin up an EC2 Spot instance using the same configurations for my existing auto scaling group, and we're able to register to the cluster. Okay, what I'm going to do now is I'm also going to scale down my existing auto scaling group just so that we can identify the differences. Okay, so I've just gone ahead and scaled it down to 0. And this will remove the other two nodes. All right, and again, you can see the node name is 134.51, and that is the newest one on my list. Okay, so let's wait for those nodes to get destroyed. And what I'm going to do is I'm going to do the exact same exercise we did earlier with the small, medium, and large, and show what the differences are between the two autoscalers. So let's go ahead and start scaling these up. We have a node that is in a ready state, meaning it can now take pods. So let's just go ahead and scale this up. Okay, so I've gone ahead and scale, and just for time, we're going to go ahead and do small and medium, and we're going to go ahead and do the large. And what I want to show is in the original model out of the box, EKS was unable to scale the large applications. Also, each of the nodes had what we call waste. So we want to see how Spot Ocean addresses both of those within this EKS cluster. Okay. So you can see this is starting to come up. So what we see is they are going into a pending state. What we want to see is how fast we can scale up to meet those specific requirements. Okay. Let's take a look. You can see immediately we've now spun up 2 new instances of different sizes. Again, before we were limited to a specific instance type within that auto scaling group. Again, if you're using Spot Fleet, you're also limited to a specific number of instance types, which really limit the possibility for maximizing the CPU and memory of those nodes. And for every scaling event, we will launch based on those requirements. So you can see here, I have the following pods that went into a pending state. We are showing what was the overall CPU before the scaling event and what was the overall CPU and memory after the scaling event. And this is where our logic comes in, is based on what you need in real time. We're able to identify what is the best instance type and size, factoring in price, availability, and any restrictions you may have, whether that's PVCs, PDBs, etc. So you can see here, we've decided to launch these 3 instances because we felt that this would be the best sized instance for these specific workloads. You can also see that we automatically are going to use high availability best practices, and we're going to separate them across the availability zones that you define. So if you have more than one availability zone defined inside of your cluster today, we'll automatically distribute your infrastructure as much as possible. So again, I can go back and should see now these 3 nodes or 4 nodes are all running. And if I jump back to my console, I should take a look and see that I should now have 4 nodes registered. So let's take a look at the specific pods and see if any are in a pending state. None are in a pending state. So this is definitely demonstrating how Ocean by Spot was not only able to allow you to consume the different pricing constructs within AWS, especially consuming EC2 Spot, but we've also done so in a way where you've been able to eliminate that waste and eliminate any manual intervention in order to get these larger applications running. Okay. And again, if I just go ahead and refresh this real quick, what you'll see is we have now optimized one of the nodes to be well over 99% on the memory. And what will happen is over time, we'll refactor this and get it down to 3 nodes. We do this on a 5-minute basis where we're always recalculating your applications in real time to determine what are the best nodes at all times. Now, as many may ask, EC2 Spot do come with some caveats, and that's where we can assist even further. If a specific EC2 Spot instance were to become reclaimed or no longer available, we have an SLA on all capacity. And what does that mean? We are going to detect when that interruption is going to occur, spin up a new Spot instance in another market, either a different instance type, a different availability zone, and then gracefully drain your application and move them to the new node. We're going to do this all before the node is ever terminated. So an example would be if I had a 5-node cluster and one of my nodes was going to be terminated, at no time would my 5-node cluster go down to 4? We would go up to 6, move the workloads over, and then terminate that one node and go back to 5. And that's what we're guaranteeing, is that at all times your applications will have compute resources to run on, and you can forget about managing or scaling the underlying application. Now, how do people today manage different applications, different teams, labels, taints? Well, what we do is we do this in a very simple, single pane of glass, what we call launch specifications. So before in EKS, you would need to create another auto-scaling group for each different workload. Right? Each auto-scaling group would define those labels and taints. Again, a big manual process. Well, here, you can simply import any of those auto-scaling groups, or you can configure them manually on the fly, and you can define all of that information right here in a single dashboard UI. Again, this is all done Terraform, Ansible, etc. And you can add these specific labels and taints on the fly, and you can immediately support a new application in your Kubernetes environment very seamlessly and easily. Okay. So some other highlights I would like to show within the Ocean cluster is I'm going to go ahead and just quickly show you a more mature environment, just to give you an idea of what else Ocean brings to the table. So let me just go ahead and quickly switch over. All right, and I'm going to go ahead and find a mature Kubernetes, specifically EKS cluster, to show you the other features that we have today. All right. So here is a more mature cluster. And what I want to show is that not only are we using a variety of different instance types and sizes, but this is ultimately what a customer's environment will end up looking like. All right, we have 16x large, 12x large, R5s, R4s, C4s, etc. Again, as I click through this, you'll see all are well over the 90% range. And this is all done automatically on the customer's behalf based on the application requirements. And again, as you see, each node is running a different number of pods because each one's running different sizes, shapes, sizes, etc. We can do that all on the fly and picking the best instance type in real time. So I talked a little bit about our cost showback feature, and this is really important as I mentioned earlier in the shared environment. So you can sort by any namespace, labels, annotations that you currently use today, and get a percentage of what applications are consuming those resources and what the dollar value is. Okay. Next, what I want to highlight is our right sizing, very similar to an automatic vertical pod autoscaler. And what this is doing is it's monitoring your applications for a 7-day period to identify when there are resources that are being wasted because the application is not actually consuming it. So we're looking at allocation versus consumption. So here's an example. A developer has requested 6 virtual CPU, but at no period of time did it request over less than a quarter. So we make a recommendation to lower that application to request fewer resources. And this is really beneficial because we have an automation so that you can change your pod requests on the fly or also directly into your repository. So as you see developers making, say, poor choices with the sizes of their applications, you can begin assisting with that effort and optimizing the applications, which ultimately will assist and optimize the underlying infrastructure. Okay. And then lastly, I want to talk briefly about our entire value add and business model. Is we are helping assist customers as a automation tool. We are not an MSP. We are an orchestration tool for the worker nodes of a Kubernetes, specifically within Ocean. And our entire business model is a percentage of savings. So it's in our best interest to help save you as the customer both time, solve those scaling challenges, as well as money when it comes to leveraging the other pricing constructs within the public cloud. All right, that is everything I really wanted to talk about today. Again, I really appreciate everyone's time and want to open the last 10 minutes here for questions, comments. The floor is open and happy to address anything. All right, I think I see the first one came in. The question is, if the nodes are so well packed, do I have to wait for a new node to boot every time a new pod is requested? That's a good question. So the way we address that today is what we have is called headroom. And headroom is what we define as excess capacity, so that your applications can immediately be scheduled and they're not waiting for a new node to launch. So if I were to demonstrate this real quick, we have what's called customized scaling, and it's called headroom. And by default, we do this automatically. So if we see a pod that's constantly being requested, we make sure that there's always a minimum of 5% of the overall cluster as excess capacity. This way your pods can immediately be scheduled and you're not waiting for the new node to spin up and become healthy. So a really good example, I've helped a large enterprise Ticketmaster consume Ocean. And whenever they do a flash sale for a ticket, there is a bunch of increased traffic. So what we've done for them is increase this headroom so that as more and more users begin to come to the specific web site, the Kubernetes cluster has the capacity to allow those additional connections. It will continue to scale up as the traffic increases. Okay, and any other questions? Anything, like I said, this time is for you. Don't be shy. I see one came in. How does the kubectl scale replicas? What does K stand for? Yes, today I am using an alias. So again, personal preference. I got tired of typing kubectl over and over every time I wanted to say get nodes. So instead of saying kubectl every single time, I just say k get nodes. Oops, if I can type. And you can just set up, depending on what operating system you're on, you can set up an alias, both Linux and Mac. You can put that inside your profile. Similarly, I have an alias for ls-l, which I use as ll, just very similar to Linux. I can share that with you. It's, again, just an alias within the profile. Let's see if I can find. It's going to be in my. And you can see here, I've just set an alias. And I'll go ahead and I'll just put that in the chat. But again, it will go inside your bash profile or depending on what OS. Okay. Good question. Looks like there's another one. Does the right sizing automatically change the pod allocations? That could be dangerous. What if the pod needs more resources after the recommendation is applied? That's a good question. So in this example, we are making very conservative recommendations. In this example, you'll see all the recommendations are to decrease, but we also have some that will say increase. So very important. We are very conservative, and our automatic right sizing is available. So by default, it's a reporting tool. We want the owners of the Kubernetes environment to talk to the product owners or the application owners to verify that these changes are, suitable, but we do have a way to do it automatically. And we do so by doing that on the fly with a webhook or making changes directly into the pod definition inside your repository, whether that's in GitHub, Bitbucket, etc. So those can all be configured. All of this is available via API as well, so you can export and retrieve this information for your specific applications to make those recommendations. So again, it may seem dangerous, but we take a very conservative approach, and we must have that pod running for at least 7 days so that we can detect if there are any spikes, any anomalies, so that we know we'll never starve that specific application. And worst come to worst, if it were to happen, the node will always have that excess capacity, so it can always go above the request size. The request is just the initial request for the application, not what it actually consumes. Here's another question that came in: how to handle sudden spikes for cluster auto-scaling? Does it take 1 to 2 minutes to bootstrap a new node in a cluster? So if I understand this question correctly, essentially you're saying if there's a spike in traffic, maybe I have a horizontal pod autoscaler that is essentially going to add more and more pods, right? It's going to scale my deployment up. If that's the case, in a normal environment, it would take anywhere between about 1 to 2 minutes for a new node to become healthy. And what that means is you're launching a new instance, waiting for the kubectl to be installed and kubeproxy to be registered with the master nodes, or in this case, the EKS service. And once that becomes healthy and ready, pods can then be scheduled onto those nodes. So traditionally, how do customers outside of Spot.io handle a spike in traffic? Well, traditionally, I've seen where customers have a lot of waste, right? They just have idle resources waiting for that spike, or they will wait for the spike to occur and launch based on some metric, whether that's number of users, number of bandwidth, CPU, memory, however you have it set up, and then wait for that to scale up. And again, as I mentioned earlier, some of the challenges with that is during every scale up exercise, there's what's called a cooldown. So if I scale up 5 nodes, I have to wait 5 minutes before I can do another scaling event. And sometimes that is too long. And that is where Ocean by Spot.io has come in. We are not going to have any cooldowns. We are scaling based on any pending pods. So as soon as something hits the Kubernetes cluster, we're scaling immediately. Again, this is also addressed by our headroom so that we can always have that excess capacity. All right, and I think that's we're getting close to the top of the hour. So I want to again thank everyone for joining today. I hope we were able to show not only the benefits of Ocean, but also some of the common challenges with EKS Kubernetes today. And again, my contact information is available. Please feel free to reach out if you have any other questions. And if you want to get started, you can just go to spot.io and sign up for a free trial. And you can begin leveraging this entire solution within your environment. Thank you again.